22, 7b255, hyperbolic geometry, angles, parallelism, wormholes formula, Wow Seti. There's the alien radio signal. And then we're talking about the angle of parallelism, hyperbolic geometry, motions, vertex, hyperbolic triangle, asymptotic, parallel, segment, lattice point, nodes, frequency signals, formula, line 22, well data. So, previous video was line 22, 7b254, antisymmetric tensor, differential geometry, hyperbolic wormholes, Wow Seti. March 3rd, 2014, the keyword is angle of parallelism. Quotes and diagrams are from wiki. In hyperbolic geometry, the angle of parallelism, also known as that symbol there, is the angle at one vertex of a right hyperbolic triangle that has two asymptotic parallel sides. The angle depends on the segment length A between the right angle and the vertex of the angle of parallelism, that symbol there. Given a point off a line, if we drop a perpendicular to the line from the point, then A is the distance along this perpendicular segment, and the symbol is the least angle such that the line drawn through the point at that angle does not intersect that given line, since two sides are asymptotic parallel. And then we have this diagram here that shows the angle of parallelism, formulated as the angle between the x-axis and the line running from x, the center of Q, to y, the y-intercept of Q, and b, the angle from the tangent of Q at y to the y-axis. And then for some hyperbolic motions in the half plane, see the ultra-parallel theorem. March 3rd, 2014, my thoughts. This reminds me of a closed end small one to the open end big one Q for the transversable wormhole. Formula from data: hyperbolic geometry, angle, parallelism, and then that symbol known as that symbol. Angle, one vertex of a right hyperbolic triangle, tetrahedron. Two asymptotic parallel side. Angle depends on segment length, A, between right angle and vertex of a angle of parallelism with another symbol. Given a point or node and signals, frequencies, wires, and that's DARPA. And then we have Cougar, hollow core fiber optic wires off a visible lights line laser beam. Drop A perpendicular to the line visible light from the point, node, laser beams, and signals. Then A is the distance along this perpendicular segment, and the symbol is the least angle. The line drawn through the point at that angle does not intersect the given line equation. Two sides, two superlattice walls, are asymptotic parallel. Angle, parallelism, and then we have a symbol there, formulated angle between x-axis, line running from x, and the center of Q. Quantum levitation to y, hyperbole space, the y-intercept of Q, and the linear parallel laser beams, and B. Angle from tangent of Q at y, the y-axis, hyperbolic motions in half plane, see ultra-parallel theorem. And on Google, the keyword tangent, and the quotes and diagrams are from wiki. So there's some calculations there and some numbers on the y and x axis. At each point, the line is always tangent to the curve. Its slope is the derivative. The positivity, negativity, and zeros of the derivative are marked by green, red, and black respectively. Formula from data: each point, node, signal, frequency, always tangent to curve. Its slope is the derivative, positivity, negativity, zeros of the derivative marked by green, muons, red, visible light, black holes, dark matter, respectively. I got a little plus there. And the keyword derivative will be in the next video. Thanks for watching.